Good morning, everybody. Today we'll discuss on homogeneous catalysis. A catalyst is a substance which increases the rate of a reaction. In homogeneous catalyst, the catalyst is in the same state as the reactants. An example of a homogeneous catalyst reaction is a reaction between peroxide disulfide and iodide. This is peroxide disulfide ion, S2O8 2 minus. This ion is negative. This ion is an anion. The full structural formula of peroxide disulfide is as follows. You have the 2O group, 2 atoms. This is the peroxide group. And you have one sulfate and one sulfate, peroxide disulfide. So here you have the peroxide group and also you have the disulfide group. It is di-negative, it is a negative ion. The reaction between iodide and peroxide disulfide giving iodine and sulfate ion. Iodide is negative, peroxide disulfide ion is also negative. These two negative ions repel each other. So difficult to collide, difficult to react. The activation energy is high. Two negative ions to collide having high activation energy. Why activation energy is high? Because the ions repel each other. Activation energy is high, so the reaction is slow and there is repulsion between negative ions. For this reaction, we can use a catalyst. Transition metal ions are often used as catalysts. Why transition metal ions are used as catalysts? Because they have variable oxidation states. In the reaction between peroxide disulfide ion and iodide ion, we use ion 2, we can use ion 2 as catalyst. Ion 2 can oxidize to ion 3 and ion 3 can reduce to ion 2. In a catalyst, in a catalyzed reaction, the catalyst must remain unchanged at the end of the reaction. So in this reaction, ion 2, which is a transition metal ion, reacts with the peroxide disulfide ion, giving you ion 3 and sulfate ion. Ion 2 is positive and peroxide disulfide ion is negative, so they can easily collide, easily attract, easily react. The activation energy is low. We have used ion 2 and a different reaction is taking place where the activation energy is lower. So there is a reaction. The ion 2 is transformed, is converted to ion 3 and increase in oxidation number. There is an oxidation of the ion 2 to ion 3 and the ion 3 now being positive will react with the iodide ion giving ion 2 and iodine. So we get back again the ion 2 which is the homogeneous catalyst. Iodine is whole and we can show the presence of iodine by testing with a small amount of starch where we get a blue color fold. So here we have the energy diagram for the reaction catalyzed and uncatalyzed reaction. As you can see, using ion 2, the different route followed requires a lower activation energy. The reaction is fast, the reaction takes place without heating. So this is an example of a homogeneous catalyzed reaction. A homogeneous catalyst must be in the same state as the reactant. An example of a homogeneous catalyzed reaction is a reaction between iodide ion and peroxide disulfide ion. Here, ion 2 is the homogeneous catalyst. Thank you very much for your attention. See you next time for another lesson. Goodbye.